Everyone. In this video, we are going to see how we can find a gradient vector for a given function. Okay, so suppose you have a function of two variable x and y. Then the gradient vector is denoted by gradient of, okay, now gradient for the two-dimensional x and y, it is nothing but it's your derivative, partial derivative with respect to x, partial derivative with respect to y. Okay, so gradient of f is nothing but partial derivative of f with x, comma, partial derivative of f with y. This is in the component form. When you are writing it in the standard form of a vector, it is given by the gradient of f with respect to x plus the partial derivative of f with respect to y and g. Okay. Now, similarly, if you have a function of three variable x, y, z, in this case, you denote the gradient del as derivative with respect to x, with y, and z. So basically, you are finding the partial derivatives of the given function. So the gradient of f is given by, in the component form, by this, all three partial derivatives separated by comma, okay, and in the standard form as the partial derivative of f with x, with I, j, and okay. Now, sometimes they may ask you to find the gradient at a particular point P. They may give you the point as say A, B, C. And in that, what you have to do is find up to here. Then, what you do? You find the gradient of f at the point P as just replace in this value. You will get the value in terms of x and y. Okay, sorry, for this, the point P will be only having two values A and B. So just replace x by A and y by b. You will get your value. And in this case, replace x by a, y by b, and z by c. And you will get your answer. Let's work on it. So suppose they ask you to find the gradient vector for this function. So let's name your function. Now here you see two variables x and y. So your function fxy is sine of x square plus y square. You have to find it at this point P, 2 and 3. So we will work on the point later. Let's have this. Now we know that the gradient of f needs the partial derivative of f with respect to both the variables, with respect to x and with respect to y. So, given this function, let's differentiate it with respect to x. So, as we studied in partial derivative, when we are differentiating with x, we consider y as a constant. So, when you differentiate, derivative of sine is cos, the bracket remains same, times the derivative with respect to x of the bracket. Okay, same like using the chain rule. So you are differentiating with respect to x, the function of x. So which is x squared, giving you cosine of x squared plus y squared times 2x. Okay, so this is the partial derivative of f with respect to x. Similarly, finding the partial derivative of f with respect to y. What we are going to do? We are going to consider y as a constant. So what this gives you, starting with this function, sine become cosine x square plus y square times the partial derivative with respect to y of the function x square plus y square. So what you are differentiating? Y. And you see y only here. There is no y, so the derivative becomes 0. I hope you understand that this becomes 2x and this becomes 0, giving you 2x. Same way, it becomes 0 and this becomes 2y. So this gives you cosine of x square plus y square times 2y. So the gradient of f, substituting in this formula, what you get? Gradient of f is 2x cosine of x square plus y square I plus 2y cosine of x square plus y square j. Okay. Now, you want it at point P at x equal to 2 and y equal to 3. That is at the point 2, 3. What you have to do? Change x by 2 and y by 3. And you get your value. So it's up to you. You can even do the calculation here. So now let's work. So it is del f equal 2 times 2 cosine of 2 square plus 3 square I cap plus 2 times 3 cosine of this remains same and j. So this gives you 4 cosine of 4 plus 9, that is 13, and then 6 cos of 13 j. So this is your gradient f. Okay. If you have time, you can find the value of cos 13 by calculator and simplify to get the answer in terms of I and j. Okay. Be careful that here you have to use the calculator on radians mode because these are numbers, not the angles in degree. Okay. Moving on to next question. Again, they ask you to find the gradient of the function at this point. They'll just change the functions. Okay. So if your function is again of two variable, tan inverse of say xy. So what you will do? You have to find the partial derivative with respect to x. For tan inverse of x, derivative of tan inverse of x, if you recall the formula, what it says, 1 over 1 plus x squared. So whatever is in the bracket of tan inverse, you have to square that number. So this will give you 1 over 1 plus xy and its whole square times. Since it's a partial derivative, you are considering y as a constant. And since you are having two terms here, so you are going to use the chain rule, the derivative with respect to x of xy. So what does it give you? This gives you y. Okay, so you get your answer as y over 1 plus x square y square. Okay, or you can write, you can keep it in the same form because later on you have to find it at a point. So xy square. Similarly, finding the partial derivative with respect to y, keeping x as a constant. What you will get? Same thing, 1 over 1 plus xy square times, what is it? The partial derivative with respect to y of xy. So in this case, what you will get? You get here x because the derivative of y is. So this gives you x over 1 plus xy and its whole square. Okay. Now, you know that you have to find the values at these 2 points. So x is equal to minus 1 and y is equal to 1. As I was telling you before, you can substitute the value of x here as well, x and y here. Okay. Otherwise, you can follow this way. Gradient of f as writing down the formula, the partial derivative with respect to x, partial derivative with respect to y with j. First writing this. So it is y over 1 plus xy square with I, x over 1 plus xy square and j. Substituting it, what you will get? Y is 1. 1 over, what we are doing here, we are finding del f at which point? Minus 1, 1. So this gives you 1 over 1 plus minus 1 square, because if you multiply x and y, you get minus 1. And then minus 1 over 1 plus minus 1 square. So this gives you 1 over 2 I minus 1 over 2 g. This is your gradient of f, gradient vector at this point. Let's take another question which involves the three variables. So here you can look at it. It involves the variable x, y, and z. So in this case, you have to find all three partial derivatives. So your function is ln x plus yz. Okay, so ln function. So it means for the gradient f, since it's having three variables, it is partial derivative f with respect to x, y, and z. You will be requiring to solve all this. So let's do it one by one. When you differentiate with respect to x, what you are going to do? You are going to keep yz as a constant. So by the definition of ln, it is 1 over whatever is in the bracket that goes into the denominator, x plus yz, times the derivative with respect to x of x plus yz. So when you differentiate, you will get the derivative of this term as 1 and here it's 0 because there is no x. So basically you left with 1 over x plus yz. Okay. Now differentiating with respect to y. When you are differentiating with respect to y, you have to consider x and z as constant. This gives you 1 over x plus yz times the derivative with respect to y of x plus yz. So for x it becomes 0, y is 1 and z will be same. So you get 1z or z. So you get your answer as z over x plus yz because this z you multiply with 1. Okay, moving forward, what you will have? You have to find the derivative with respect to z. So this is 1 over same x plus yz and differentiating with respect to z, x plus yz. So for x it becomes 0, for y you keep same and for z it's 1. So you have 0 plus y which is y multiplying with 1 gives you y over x plus yz. So this gives you the gradient of f because 3 dimension now. So 1 over, we are using this, 3 values, 1, 2 and 3. 1 over x plus yz with I, z over x plus yz with j, and y over x plus yz with k. Now, if you are finding del f at this point, 2 minus 1, 1. So basically, this is the value for x, y, and z. Substitute it. So what it will give you? 1 over 2 minus 1, I. Z is 1 over, denominator will be same. Okay. And it's minus 1 over 2 minus 1, k. So you get your del f at point 2 minus 1, 1 as 1 over, say denominator gives you 1. So you have I, 1I, or you can write I plus j minus k as the gradient. Okay.